So, good day, guys. Welcome to this episode. So, what we are doing this episode is how to find oxidation states. How to find oxidation state of a particular atom in a compound. So, without wasting much of our time, let's dive into today's episode. So, what we are doing is oxidation state, as said earlier. So, I will urge you to subscribe to my YouTube channel so that when I drop interesting video like this, you have access to it. So subscription on YouTube is 100% free. You are not paying any man amount to subscribe. So just do yourself a favor by subscribing. So what we are doing now is oxidation state. So now let's go to our main aspect. So we have K2Cr2 07. Let me quickly introduce you to it. When they ask you to find oxidation number in a particular substance or a compound like this, so for example, if they ask you to find the oxidation number in CO2, that is, they ask you to find the oxidation number of carbon in CO2. So carbon, if they ask you to find the oxidation number, so you should know this, that when a free element like this does not carry any charge. If you look at CO2, it is not carrying any charge, unlike SO42 minus, it is carrying what? A charge. So the oxidation number of CO2, whenever you want to calculate it for that of carbon, you firstly equate this CO2 to what? 0. I hope you understand. So the oxidation number of oxygen is what? Is -2. I hope you understand. Please note this rule. The oxidation number of oxygen is what? -2. Though there is exception to this rule, it has a different oxidation number when it is in peroxide and some other compounds like that. And also hydrogen, the oxidation number of hydrogen is always 1, but except when it is also in hydride. When it is in hydride, it will be -1. For that of oxygen, instead of being -2, when it is in peroxide, it will be what? -1 also. I hope you understand. But on normal compound, the oxidation number of oxygen is what? -2. Hope you understand. So for group 1, all the group 1 elements, their oxidation number is 1. Group 2 elements, their oxidation number is 2. So you should note their oxidation number. So, and those halogens, their oxidation number is normally -1. Hope you understand. So now let's do the oxidation number for this. We are looking for the oxidation number of carbon in this compound. Before I go to this place, because I don't want to jump, so that I want to introduce you to the rudiment. So for carbon, we are looking for the oxidation number of carbon. So let's represent the oxidation number of carbon with what? C plus, then you had it. What's the oxidation number of oxygen? So oxidation number of oxygen is what? -2. What's the subscript here? It is what? 2, right? So then you multiply it by 2 is equals to what? 0. I hope you understand. You will represent this, the oxidation number of oxygen, by -2. Then how many oxygen will you have here? We have 2 oxygen. Then you multiply it by 2. I hope you understand. So it's now going to be what? C. So minus times minus, plus times minus, that's -2 times 2, that's -4. -4 times plus plus, that's what? -4 is equals to 0. Then bring this 4, bring it to this side. So it's now going to be what? +4. And there's a rule. Whenever you are finding oxidation state, if you are having plus, you should indicate your plus. If you don't indicate your plus, you are wrong. So that's it. So I think I've introduced this aspect to you. So let me rub this. So now let's find the oxidation state of chromium in this compound. So without wasting much of our time, if you look at this is potassium, and potassium has a electron configuration 2881. So it's an alkaline metal. So the oxidation number is what? 1. So I hope you understand. So the oxidation number for potassium is what? Is 1. So let's input it into this equation. So we now have what? How many potassium do we have here? We have 2 potassium. So it will be what? 1 times 2 plus. Let's represent the oxidation number of chromium with what? Maybe X or Y. We can use chromium. Let's use chromium. So it will now be what? How many chromium do we have here? We have 2 chromium. So it will now be 2Cr plus oxygen. What's the oxidation number of oxygen? That is -2. How many oxygen do we have here? We have 7. And if you look at this element also, it doesn't carry any charge, so the oxidation number of this compound is also equal to 0. So 1 times 2 is what? 2, plus 2Cr, then minus 2 times 7, that is minus 14. Minus 14 times plus, that's also minus 14, is equals to, so we now having 2 minus 14, that is minus 12. So you bring this minus 12 to this side, so we now having 2Cr is equals to plus 12. Divide both sides by 2, so our answer will now be Cr is equals to plus 6. So that's our final answer. But if you are given a question like this, Cr2O7 2 minus, if they ask you to find the oxidation number of chromium in this aspect, so your oxidation number, since this compound or this ion, this radical carries a charge, so this is how you will do it. It will be equals to minus 2. I hope you understand. So it will now be what? 2Cr, I hope you understand, plus what's the oxidation number of oxygen? Minus 2 times, how many oxygen is here? 7. So we now having minus 2. I hope you understand. 2Cr now will now be minus 2 times 7, so that's minus 14 is equals to minus 2. Bring this minus 2 14 here, we're now having 2Cr is equals to minus 2 plus 14, so we're now having 2Cr is equals to 12. Divide both side by 2, divide both side by 2, so Cr will now be plus 6. Hope you understand. So that's how to do it. So that's that for this video. Let me pick the correct answer. So the correct answer is plus 6. So this option D is, it has cancelled this self because we cannot have ordinary 4. So that's it. So that's that for this video.